Cool. Hi. Hello. My name is Mark Canlas. This is my second time speaking at Scala. I'm a big fan of Scala, one of my favorite conferences, and a big fan of Scala as well. And I'm here to talk to you about functional error handling with cats. I work for Disney Streaming. We're the folks that make Disney Plus, and I'm based out of New York, so I'm a local boy. And we use a lot of languages, and one of them is Scala. So we're big fans of that also. So Disney has a pretty strong background in storytelling. So what I want to do today is tell you a story or two about error handling. A story that involves characters that are not associated with the Disney brand. So just keep that in mind. It's an off-brand of fairy tale. So just a reminder to level set expectations. This is an intermediate talk. I will assume that you've had some experience with these ADTs, these data structures, and also that you have seen these type classes before that come from cats. So you don't have to know them completely, but at least know that they exist and that there's a relationship between them. The talk that I gave last year was a survival guide on understanding how these three relate. That functor is the weakest, and monad is the strongest and most specific. And the narrative that we want to talk about today is understanding errors as data, which is a big proponent of like the whole FP philosophy. We don't just have errors that we suffer from randomly, like exceptions or null. We want to be in control of those errors, and we want to encode them as data. And once we encode errors as data, we're free to manipulate them just as we manipulate other data. So they're no longer special, they're no longer exceptional. So here we go, a fairy tale about handling errors with cats. Imagine once upon a time, there's a far off kingdom of validation where everyone's happy, and there's a king of validation. And one day, the king's going through his royal artifacts, and he comes across a bunch of scrolls, a bunch of ancient records. And all these scrolls they're untyped. They're poorly structured. That's no way to save data. And he says, I want these scrolls to be parsed. I want them to be well structured. Is there anything that we can do? Right, so here we have a record where everything's projected like strings, like a typical like JSON raw structure, and we want ints, doubles, things like that. So we can call that workflow parsing a record from ancient record to citizen. So the king dispatches his knight, his functional knight, his knight of functional programming. And the knight says, hey, I'm here, I'm ready to go. I have functions ready to use, pure functions, but I don't know what they look like. I just know that part of my quest will involve functions that look like this. So they're incomplete. We don't know what the type signature is. We don't know what the body is. I'll leave that up to the reader as we go on. But these are like the primitives that we'll work with, and maybe we can combine them together to make one whole narrative and satisfy the king's quests. So out pops the wizard, monadic Merlin. Merlin's a wizard, he's very powerful. He knows Scala, he knows FP, and he really loves monads. And Merlin says, I know the answer to your question. And specifically, he notes that the function on the bottom, we can't account for every record. When you parse a record, there might be errors. So I cannot guarantee to you that every record will yield a record of a citizen. So we need to encode that uncertainty into a type F, right? And he says, I have the monad for you, and that monad is option, right? So now we have a specific type signature for these primitive functions. We're parsing from string to some type, but not just the type, an option of that type. And Merlin goes on to explain when things are monadic, you can stack them together into a for comprehension. Maybe you've seen this before. So right now we're stacking these parsing functions together, and we say like, hey, if everything goes good, we can get a citizen out of the whole workflow. And just like this, if each step yields a proper field, we can stitch all those fields together monadically in this for comprehension, and we get a citizen out. And Merlin also notes if any of them fail, like let's say, for example, the second step fails, it will actually mute the running of the third step. The third step won't run at all. And that will change the output of the entire for comprehension. If the second one is none, then the result of the entire for comprehension will also be none. And then Merlin calls this tale the first one wins, right? Or we can say the first error wins. It's like the first narrative of telling stories with errors, right? So the first error in this workflow will dictate the structure of the result of the whole for comprehension. So the king says, great, like I love what you're doing. I love the functions and I love Merlin. But I've developed an awful habit of using Java in addition to Scala, and I'm using Java services that throw exceptions. Do you have an answer for this? And the knight says, of course, we can do it. And Merlin hops in and he says, yes, I have a monad for that. And of course, the monad is try, right? So very similar structure as before. We're just changing the F type. And I'll leave the implementation of these up to the reader. But we notice that we can stack these tries together just the same way as we did the option. They have different return types, but if the second step fails for whatever reason, it will mute all subsequent steps and then also influence the return of the entire structure. Everyone following so far? I just want to like check chat and make sure everything's going good. Okay, cool. Right, so, yep. So the knight steps in and says, hey, wait a second, I notice a pattern here. Before you said option, now you said try. There's definitely some symmetry here. In here we can see that there's like a happy path and a sad path. Actual terminology that I've heard, I believe at Eddie Scala also. So hopefully this resonates with you. There's a happy path and a sad path with these structures, right? So some mirrors success and none mirrors failure. So the king says, wow, this is all well and good. I am so satisfied with the way things are going. I love the monads. I love the parsing of these records. But my daughter, the princess, she really loves errors as data. She's really into it. She's so into it that she made an ADT. She not only wants to capture errors, she wants to capture them in her own ADT, right? So this way we're capturing what the raw strings are and indicating where parsing has failed. And then Merlin has to step in. He's like, of course, I got you. I have a monad for this. So he steps in and says, there's an either monad. So we have the same functions as before. We're changing the F type to either. We're returning there's a little bit of a typo here because it's actually, no, wait, no, it's fine. Each function will return its specific part of the error ADT, but ultimately they're in the same type hierarchy, so they can be stacked together. And this is the same as before. We can use the for comprehension structure to stack these validation functions on top of one another. And if for whatever reason, one of them returns an error, which we call left in this case, it will mute subsequent computations and influence the entire structure. So the knight has to step in and they're like, hey, I notice a pattern. this sounds very similar to before. And the knight's right. There's a happy path and a sad path with these structures. They all exhibit the same sort of narrative of like first error wins. Anytime the for comprehension hits a sad path, that's the one that wins the whole structure overall. So the princess loves errors, and the thing that she loves even more than data as errors is she also loves microservices and web servers. So she's enjoying her functions that return errors as data. And she wants to encode these errors into some sort of destination. In this case, we're calling it the HTTP response ADT, right? So an HTTP response can either be maybe like a 200 series or like a 400, denoted here by the success and client error. So we need a way of like a presentational method, the one on the bottom, going from the either to something in that response hierarchy. And then maybe we have these two functions that deal with the specific sides of that hierarchy. If I get an error, I want an HTTP error. If I have an actual citizen record, I want to say a success. Again, leaving the implementations up to the reader. So one way that you may know of getting yourself out of an either is to fold, right? When we say either dot fold, we give a function for the left side and a function for the right side. And they should both end up in the same destination type, which is HTTP response. One style that you might not know is called left map. And here the types are spelled out on the right. Notice that when we say map on an either, we're only changing the right side. But we can also use a method called left map, and it changes the left side of the map, right? So we can call our presentational functions one at a time for each side of the either. And because we're using left map and right map, the final structure we end up with is still an either. So this is different than fold. But what we can do is if the two sides of an either are in the same type hierarchy, we can merge them and it will intelligently pick whichever side is filled out. But the type should be the same. And another way of calling this, it's a fancy word that you might hear, is a bifunctor, right? And either is a bifunctor because it's a functor over two parts of itself. It's a functor over A and it's a functor over error channel E. And then Merlin just hops along and says, hey, for your troubles, I want to let you know that there's this fun postfix syntax when you work with eithers, right? So you can just type in the payload or the error and do as right and as left, and hopefully type inference will get you to the right shape. So yeah, the king says, hey, everything goes good. Everything's going good, but I've had a vision. I've been messing with your crystal ball, and I can see in the future at 4 o'clock a talk by Guillaume on monads. And Merlin's like, of course, I can see the future as well, and I know what you're talking about. It is the IO monad from Cat's Effect. And I have good news. It's just a monad, just like everything else we've learned today. We're just changing the F type to IO. And it has the exact same semantics. It's a little harder to see because we're not privy to the ADT of IO usually, but again, the same semantics of if for whatever reason one of the computations fail, it'll influence the entire structure. So if the computation on parse name fails, or we're going to use the terminology an error is raised, that error will be displayed as a result of the whole for comprehension. And then Knight has to chime in again, and they're like, hey, there's a symmetry here, and he's absolutely correct. They're absolutely correct. There's a happy path and a sad path. Again, less obvious here with IO, but it's still the same gist of whenever there's one error, it stops everything. First error wins. And monadic Merlin hops in and he wants to show off and he says, I want to display to you the power of my magic. Uh, and I can prove to you how powerful I am by using the compiler. And he says that everything that we've talked about today is a monad. We use some type massaging here to make sure that the either is in the correct shape because we needed to have only one hole and either has two holes. So we affix a specific error type on the left side. But once we do that, you can summon the monad instance for any of these, and this should work. This should compile, right? All of these types have monadic, obey monadic laws and have monad instances for them. So if we draw everything out into a table, and we also discard option for this, we can see that all of them support a payload channel A, and all of them support an error channel. For either, the error channel is generic, but for both try and IO, the error channel is specifically throwable. So it doesn't show up in the type, but we want to talk about the fact that it does have an error channel in it. And there's actually a different type class for this. It's called monad error. So here, we're sort of highlighting the fact of what the error is. So this is a type that's stronger and more specific than just monad. So now the error type is upfront. And so if we draw out a table of everything that we've learned from last time and from this talk, we can see that there's now a more specific type class on the right side called monad error, right? This is like our entire universe of monadic type classes. Make sense so far? Everyone following along? Cool, so great. Thank you. Thank you for the responses, very helpful. All right, so everything's cool in the kingdom of validation. The king is super happy, as is the princess. But she says she doesn't want just one error. It's kind of a shame that when we do this workflow, that we're always only getting one error, right? In this parsing logic, if for whatever reason the first step fails, we can't parse age, we actually don't know anything about the next two steps. It's not that we can't see them, it's that they don't run at all. There's like no visibility, there's no side effects, it doesn't run at all. So is there a way, given like a set of these functions that look like either E and A, that can we get like a list of them, right? Is there a way that we can see what the errors are for all the steps and not just the first one? And notice something about monads, the shape that you start with is always the shape that you end with. So it kind of doesn't match what the princess wants, right? We want all the errors, not just one, but the tools that we're given always start and end the same way. So maybe this isn't the right, maybe we're barking up the wrong tree. So the king says, dispatch my knight, go find me a solution to this problem. So the knight says, okay. And the knight has no idea what to do. But the knight one day is walking through the woods and the knight encounters a witch. He's like, what? A witch? And the witch says, I have what you're looking for. I have a secret data structure that will help you. And she says, the data structure is called validated, which the knight has never heard of before. And she says, this is what you need, right? I'll take your functions and we'll use validated as the F. And notice that it uses the same error ADT that we established from before. But the witch warns the knight that her magic is different and weaker than Merlin's, right? Merlin is monadic Merlin, he's very powerful, but the witch is not the same. And she says that you cannot use 4 comprehensions with the witch's magic. It's not possible. And she sort of explains to the knight, hey, if you find yourself with these validated structures, this is the homework that you have to do manually. It's very ugly. We don't usually see this. So given 2 validated structures, If what we want is to put them as a list, let's say we have two valid ones, we can put them as a tuple, make them interact. If we have one invalid each, we can just wrap it in a list. And if we have two invalid cases, we join them together in the same list. There's a lot of manual work. It's very not fun. But she says, notice that there's a symmetry here. Even though her magic is different, it is similar to Merlin's either. So both of these cases are helping tell the tale of errors as data. And both of them are what we would call an exclusive disjunction, which means that it's either the payload or the error, but it's never both those things. There's actually another structure in CATS that does that. But this is exclusive. It's either the A channel or the E channel. And both structures are bifunctor over A and E. So leveraging what we learned from before. And the knight, very observant, says, there's a symmetry here. I see a happy path and a sad path, which is the correct intuition. And the witch agrees, and she says, there are payloads and there are error channels, same as before. Notice that validated also has a generic error channel, just like either. And she says, I can prove it. I can prove it using the same compiler that Merlin uses. And here we can prove that there's an applicative error for validated, and there's also applicative error for the other type classes that we've seen before. But the one that doesn't work is we cannot prove that validated has a monadic instance. So if we go to our type class table, sometimes I call it a type class lattice, inspired by one of Paul P's talks. Anyway, our type class table here, we just put in applicative error on the right side. So these are all the type classes that we'll, most of the type classes that we'll be talking about today. And she says, you know, for your troubles, I will give you this fun postfix syntax, just like either, if you want to call payload.valid or payload.invalid. So the knight rushes back home. He's like, Merlin, I've met a witch, and she told me about applicatives, and she told me about validated, and it's so cool. And Merlin's kind of mad. He's like, I don't like the witch, and I don't like what she's about, frankly, because her magic is ugly. She has all these validateds of E's, and then she magically ends up with a list of E. That sounds preposterous to me. That sounds crazy. Yeah, Merlin does need to chill out. He's a very jealous guy. And he says, my magic is symmetrical and beautiful. Look, it starts with E's and ends with E's. Like how much more beautiful can you get? And he has a suggestion. The least you could do is maybe start with a list of E's and end with a list. At least it would look symmetrical, right? At least it would look as pretty as Merlin's magic. So what if we took the functions that we had before and wrapped them in lists? Let's just see what happens. So it's the same as before, using the validated data type. Now we're just wrapping the payload in a list. And going back to our super ugly manual manipulation code, let's see. If we have two valids, we can make them interact in a tuple. If we have one invalid each, we can just return the payload because the payload itself is a collection. And if we have two invalids, we can just concatenate the collections together. So Merlin notices from this vantage point, if we pull out the collection type and drop in semigroup of F, the concatenation is replaced with just a semigroup operation, semigroup plus, I guess you would call it. So it's not that it's not that it could be a list. It could be any F that has a semigroup defined for it. So that's actually a really good intuition. When you think of validated, in general, it's not just validated of E of A. It's validated of F of E and then A. For any F that supports semigroup is probably when you would use validated the most. And if you can set this up correctly, if you have structures that all return validated of a list or validated of a semigroup structure, you get this fun syntax. Maybe you haven't seen it before. So you get a tuple. Every value in the tuple must be some sort of validated of a collection of the same error type. So it's a lot of requirements and the same payload. But if you stack them together, you can call map n, and that assumes that all of the calculations are valid, and then you have access to them, and then you can construct a citizen, or you get all the errors stacked together into one list. So this is kind of like a four comprehension equivalent, because as we learned earlier, you cannot use four comprehensions. This is not a monad, right? And I think I looked this up yesterday. This replaces what was the Cinnabon operator. I guess I'll type it in chat. It's like bar at bar, or the akbar operator. I think that's deprecated, so this is like the new way to go. And the princess is totally happy. She's like, hey, this thing does what I wanted. It lets me see all the errors. So if you're ever in a scenario where you have a validated and it has errors on it, you can treat it the same way as either. You can fold on it. If you have the two individual presentation functions, you can fold on it. Notice that we don't have just one error, we have multiple. Or we can use left map because it's bifunctor. And similar to either, it has merge. Both sides of the validated are in the same type hierarchy. We can merge them together. Can everyone still hear me? I got like a notice that my internet was choppy. Okay, great. Thank you. Cool. So I think that's near the end of our story, right? We learned about two styles of telling stories with errors. We learned about first error wins, and we learned about accumulated errors. So first error wins is a good way of modeling dependent calculations. One workflow that's necessarily dependent is if you're ever unwrapping envelopes or nested envelopes or decoding. And you would also want to use this if you want to introduce dependency on things that are not dependent on one another. One example is if you are talking to like an auth server and that's very expensive and you want to gatekeep people from that, even if that call can be made independently, maybe you want to use monads to stop people from doing that, right? They have to earn their way up to that expensive call. You would use accumulated errors if you wanted to, anytime you're modeling like a validation on something that has a lot of fields, like a map, a record, or an object. It's also good for minimizing round trips, because if you were doing first error wins and people need to fix their payloads based on your feedback, if you're only telling them one error at a time and they get a lot of stuff wrong, they'll never know unless they hit your server multiple times. So if you're okay telling people everything that they got wrong at once, maybe the accumulated error model is for you. And also the way the errors get calculated can be parallelized, hypothetically. Cool, so the king says, everything's hunky-dory, this must be the end of the presentation. And the queen of collections comes by and she says, not so fast, there's an improvement to be made. She notices that whenever we use validated and there's a list of errors, actually, when we have errors in validated, there's always at least one, right? Because if everything's successful, we use the valid side of, or the right side of the validated. But if there's an error, there's always at least one. You can't have like an empty collection of errors that's expressed in a different way. So you can use a stronger type from cats, and you can use non-empty list. And notice that non-empty list on the bottom also has a semigroup instance. This compiles. And the princess notices, you know, for our troubles, if we use non-empty list for validated, we get this fun postfix syntax, payload.validNel or payload.invalidNel. So the king thinks everything's great. Nothing could possibly go wrong. But he notices that he's feeling slow and sluggish every time he interacts with lists. He says, oh my gosh, I feel so sick when I manipulate lists too often. I feel slow. And the queen of collection says, I know what the deal is. Did you know that lists performance is only performant at the left side, on the head side? So you can only prepend quickly or read quickly from the left side, which makes appending very slow and painful. So just to go through this really quickly, it's not the highlight of my presentation, but if we were to append two lists together, you could either spend your time traversing your way to the end of the first list and keep chopping off values and prepending it to the target list. So you're suffering from repeated traversals dependent on the length of the list, which is slow. Or you can spend two whole traversals of the list by building a reverse list. So here we're lopping off the left side each time and building a reverse list, one element at a time. And then you would reverse the reverse list back onto the target list. Either way, lists are not fun for appending accumulation, which is what happens a lot with cats and monads and things like that. So the queen says, what if we can imagine a world where we're not even talking about just lists, any sequence, let all the sequences be. Is there a way? And she says, let there be chain. There's a data structure in cats called chain. And what it does is sort of, instead of rewriting collections each time you add something, it just sort of takes the sequences as they are and stitches them together. So that it has performant append and prepend operations. So if we just drop in the word chain for our workflows, this works, right? There's the semi-group for a chain. It's a collection that we can use. But also the same observation from before works. It's not that we ever have 0 errors in the error channel. So there also exists a non-empty chain. So maybe there's a lot to take in, but here's a summary of all the collections that you have available to you for validating potentially. List, non-empty list, chain, non-empty chain. 3 of which come from cats, so it's a lot of new information. But notice that the chain has better performance, specifically for the use case that shows up with cats a lot, especially with traversals, which is sort of outside the scope of this presentation. But again, for your troubles, if you super love non-empty chain, you get valid neck and invalid neck as fun postfix syntax. So that is the bulk of my presentation. And let's, I just want to mention some topics that we're not going to go into in depth to, but just as a sort of springboard of where this brings you. What are some future topics that you can think about in relation to this slideshow that you can look up in the future? One, we didn't talk about algebras. So we were always using specific Fs, but you can sort of write your code at a very generic level. Yes, future topics, but never topics about future. We can also talk about methods that exist on the type class. I had a hard time writing a slide for this, but basically the type class applicative error and monad error exist also to give you more operations, but the operations are less obvious. But one thing to note about using these error channels in a functional context is that you can still use exceptions, but think of them as like a data structure. And you don't throw them, you raise them. It's just terminology that puts the error into a managed channel that the library expects rather than sort of throwing them wild Java style. So it's not verboten to use exceptions, but it is verboten to throw exceptions. But this is totally cool. Raising an exception because you know the error channel is throwable. One thing that also comes up, the more you get comfortable with these like error channels, sometimes you might have multiple error channels for different Fs, for different types. So sometimes you might have F and G that are nested. This comes up if sometimes, I think the most common one I've seen is like IO and either used at the same time. And an extension of this is also monad transformers, which sort of tries to address how nested Fs and Gs interact with one another. So I'd like to thank the folks at Type Level for making this super awesome cats library. I got most of my information from the docs. You can read about chain and validated, which are data in the data types section of the cats microsite. And please check us out. Disney is always hiring, jobs.disneycareers.com. And you can also additionally filter by Disney streaming, which is where I work in New York, and where we use Scala to make Disney Plus run. And you can find me on Twitter, Mark Canlas NYC. So any questions? Just looking through chat now. Cool. So there's a question here, and I don't know how to use the features to answer it super slickly, but it says, if you have error handling with cat's effect, which approach do you prefer and why? We have IO and raising errors. We have IO with a nested either, or we have the either transformer or something else. So we actually had a bit of a discussion about this at work. Monad transformers introduce a lot of other methods that I don't think are clear, because they're already kind of confusing. They're called like semi-flat map. It gets into this weird thing. Basically, monad transformers allow you to sort of focus your zoom. So when you nest, sorry, it's a mouthful. So when you have two effect types like F and G, you can either analyze the payload of the F or the payload of the G. But the payload of the F might be G of another payload. So there's just sort of onion effect that needs to happen. So monad transformers allow you to sort of treat F and G as one layer so that you can only focus on the payload. And I haven't had enough experience to come up with like a super strong opinion on what to use and when, although I think monad transformers can be a bit cumbersome. I will say though, there are times where the domain dictates that the error types need to be that complex. So I think if you earn your way up to that complexity, you definitely need to use the right tool. So, IO either is not terrible, and neither is a monad transformer. It's just earning your way up to it. Because I've seen code bases that use monad transformers right away and all the time, especially for contexts that are not needed. So yeah, as long as you earn your way up, I think it's fine. And regarding like raising errors in IO, it's understanding the difference between which errors are recoverable and which ones are not, right? Which ones do we want to be fatal and we want to stop everything and we cannot guarantee successful running of the program, or which errors do we want to handle and recover from in a controlled, thoughtful way? Hopefully that answers your question. Yep. Any other questions? If not, I think there's still time. Cool. Well, if that's it, I'll be online all day to look at things. But I want to thank you and thank everyone for coming to my talk.